multiples today, and since it's Pi Day, I thought I'd start with kind of a nerdy math one. This is the distribution of leading digits if you start multiplying any number by 2, basically. So the first tall green yellow bar is 1. So 1 is the most common leading digit. So for example, we're starting with the number 3. So then you put a little mark in the 3 column. 1, 2, 3. And the next number is 6. The next number is 12. So the leading digit is 1. I thought it was kind of curious that you get this distribution. I think the distribution of trailing digits, for example, ought to be flat. It ought to be kind of random. But for some reason, just natural numbers give you this kind of exponential decay of probability of which number is going to come first. Inside of that, this is an example of small multiples in several ways, I think. The first way is that each bar is really a small multiple. Inside of that, you see where the preceding number was. So if you want to get to the leading digit of 1, and you're multiplying by 2, your preceding one can be 1, 2, 3, 5, 6, 7, 8, or 9, right? So 9 times 2 is 18, so then you came from a 9 to a 1, and so forth. The thing that I thought was kind of cute, another thing about these small multiples is if you add up all these blue bars, you get to, of course, the tall bar. So the only way to get to a 2, when you're multiplying by 2, is if your previous digit was a 1. So that's why this one is this tall. Likewise, the only way to get to a 3, well, you can get to a 3 from a 2, so that's like 25 or 15 or something. But the thing that I thought was kind of funny is if you multiply by different numbers, the blue bars dance around quite a bit. So if you multiply by 3, you have all these different ways to get to a 1, right? You can get to 1 if your preceding digit was a 3, 4, 5, or 6. You can get to 2 if you had a 5, 6, 7, or 8, or 6, 8, 8, or 9. The thing that I thought was kind of cute was no matter what the given factor is, the yellow bars just don't budge. They just don't budge at all. This is just the distribution of leading digits. But the way you get there, of course, changes. So the blue bars dance around a bit. Oops, 46 is not going to be good. The cute thing there is the blue bars dance around a bit, and yet somehow these yellow bars know how to stay the same. I thought it was kind of cute for Pi Day, but I'll move on to some more interesting data graphics showing actual data. This was an exploration I did to see the effect of the No Child Left Behind Act, which was George Bush's education initiative where everyone had to pass a test by a certain date and so forth. What I'm showing here is Illinois test scores. On the x-axis is percent passing. So when you go to the right is good. The red curve is for all students, and the blue curve is for students with economic disability, so-called free or reduced lunch. So in the upper left, that's third graders in 2002, moving over fifth graders, eighth graders, and high schoolers in 2002. Going down, you've got years from 2002 to 2007. So again, in the upper left, we see that there's kind of a two-hump wump. The kids that are on free lunch do quite poorly compared to the average. As you move down in time, you see that blue hump is kind of moving over to the right. So maybe the gap is decreasing. The so-called gap was a big buzzword during No Child Left Behind times. And it's true for fifth grade, the second column, as well as eighth grade. The third column, the blue curve is meeting up with the red curve. Isn't this good? We're decreasing the gap. But for high school, that doesn't really happen quite. You can see if you move straight down, really the distribution doesn't change at all. That was kind of perplexing for a while when I found out that the high school test is tied to a college entrance exam. And the state isn't allowed to change that. So it seems like the likely explanation is in order to pass No Child Left Behind, Illinois and many states perhaps, make the test easier and easier, which not only kind of falsifies the education process, it makes it look like you're decreasing the gap between subgroups, and perhaps you're not at all. If we look at the same thing, except not educational disabled, but different races, the pink curve or the orange curve is white kids, and Hispanic and black are the blue curves. And again, you see the same kind of pattern. There's a big gap at the beginning, and it seems to have changed. You also see that all the curves are kind of tilted this way, which made me think that they're just making the test easier. And again, high school, things aren't changing at all. In order to kind of account for the fact that the test may be getting easier, you can standardize these curves. You can do something called normal curve equivalencies, where you say, okay, well, let's renormalize the bell curve of the standardized test so it's always centered at 50 and has a standard deviation of 20 or something. And you say, well, how do things look if you renormalize it that way? In that case, really, you see that there hasn't been much change from 2002 to 2007. Things, in terms of the gap anyway, have stayed pretty much the same. overall, all grades and all years. I thought it was interesting to look at this exact same curve. Now, again, test results on the x-axis, high is good. For Chicago, Chicago's kind of interesting. For the lower grades, well, just about everyone is economically disabled in Chicago, I guess. But the interesting thing is in high school, you've got this two-hump bump. You know, somehow in Chicago, they have really excellent high schools for some kids, and for most kids, not. Kind of interesting. So again, that's just a subset of all Illinois, just based on Chicago. And to look at the country as a whole, I made this graph, which again shows different No Child Left Behind subgroups. So each color represents a student subgroup. In this case, the x-axis is years. The time's going by this way. And on the vertical axis is test scores. So over the No Child Left Behind law, all subgroups moved up. Everything's going great. I think the main result is that the tests were simply made easier. If you, again, look at this normal curve equivalency, you'll see kind of a flat rate, and maybe even a diverging of the different economic groups. Maybe the colored kids are getting even farther away from the white kids. So it's just my quick, small multiple investigation of No Child Left Behind. Thanks. I also did this for other states. It's kind of curious. You can see it for other states. But if there are any questions,
I have a question. So, did you do this to assess something that was of interest to you, or is it for like researching for the education?
There's a company in Illinois called Academic Development Institution I was working for in this case. Okay. I did these graphs basically on my own. They wanted other things. They wanted more look at things this way. You know, how do kids do in different situations, and make rankable tables or whatever. And I kind of went on my own and did those graphical things because I was more curious about what
easier to see relationships.
Yeah, really see it. They didn't really care much for my graphics. I thought they were pretty cool.
The hard data.
Yeah, not for everybody, no doubt. Well, thanks for your attention, guys.
Okay.
Cool, thanks.